In this video, our objective is to be able to go from a surface area to a volume within a similarity problem. So far we talked about finding area or volume in separate problems. And now we're going to take both those ideas and put them into one problem. I'm going to draw a diagram at the top of the notes. If I have an area ratio, and I want to go to a side length ratio, I'm going to square root it. And if I want to go to side length to area, I'm going to just square it. If I add a third item here, the volume ratio, if I go from side length to volume, I'm going to cube the ratio. If I go from volume to side length, I'm going to cube root it. So if someone were to start over here at volume, you could work your way through to the side length by cube rooting, and then over to area by squaring. Likewise, if you were to start at area, you wanted to go to volume, you'd first square root it, then cube it. As long as you keep this diagram in mind, these problems become much easier. So in this first example, the volumes of two similar solids are 1,728 cubic meters and 125 cubic meters. The surface area of the larger solid is 180 square meters. What is the surface area of the smaller solid? So they are asking us to find surface area. So find surface area. But in order to find surface area, we need a surface area ratio. We don't have a surface area ratio. What we have is a volume ratio. So we have to go from volume to surface area using what we talked about up here, the diagram. So the volume ratio is 1,728 over 125. So to go from a volume ratio to a side length ratio, we're going to first cube root it. So the cube root of 1,728 is 12, and the cube root of 125 is 5. So right now this is side length. To change the side length into an area ratio, we're going to square it. It's going to be 144 over 25. Now we have an area ratio, or in this case a surface area ratio. So we found our surface area ratio. We now need to find our surface area. So use 144 over 25 in your proportion. They give you the surface area of the larger solid, 180 square meters. 180 will go on top because it's the larger solid, and this is the larger number, 144, over x. Cross multiply, you're going to get 144x equals 180 times 25. And you get 4,500. Divide both sides by 144. And x is going to be 31.25. This is going to be square meters because it's surface area. So to recap, they asked you for surface area. In order to find surface area, you need a surface area ratio. Currently we don't have one of those. We didn't have one in the beginning. So we took that volume ratio, turned it into a side length ratio, then turned that ratio into an area ratio. And once you have that area ratio, you can set up your area proportion. Don't make the mistake of using the volume proportion instead of this one here. You can't set up a volume ratio with an area ratio. The two ratios have to be the same type of ratio. So let's go back to our diagram. What we started with was a volume ratio, so this star over here, and we moved through the diagram over here. So first you cube rooted, and then we squared. Keep track of where you're starting and where you're ending, and how you're going to move through that diagram, and set up your proportion correctly.